Hi guys, today we will be discussing statistical inference, estimation for single population. We have already learned about sampling distributions. Now what we want to find out is how to estimate population mean using only random samples. Now recall that sample is only a subset of the population. And so what we want to do right now is how to use these random samples in estimating the mean or the average of a population. Before proceeding to the actual formulas for estimating single populations, it is first important to know and understand what a z-score table is. A z-score table contains all of the percentages of values or area percentage to the left of the z-score. Now recall about our previous discussions about the normal distribution. In a normal distribution, there is a bell curve, and under that bell curve or the spaces under it is called an area. Now sometimes we want to locate certain portions of that area, and we want to find out the percentages that a specific value can be located in that particular portion. In z-score, we can measure how far those values are in that portion from the mean. And so the z-score table uses the z-score and converts it to percentages. The z-score table is basically like a conversion table from z-score to actual percentage. So now we will start to understand the z-table and actually put it to application to sampling distributions. The most important thing to remember here is the formula. The formula that we will be using is z is equal to x minus mu or mean all over standard deviation over the square root of n. Now, here are the steps in understanding the z-table. The first step is to understand the problem. Now that you have the formula, you need to locate the different values required in order for you to compute for the z-score. Now, what you need to look for is the mean, the standard deviation, and the sample size. Now, for this formula, let's say the mean is 50, the standard deviation is 10, then sample size is 64. Now, after that, the second step is to list down all the given in the following format. Mean is equal to 50, standard deviation is equal to 10, and is equal to 64. And notice that these are all populations except for n, which is the sample size. And then to the right of this given, you write down the distribution of x, n, open parenthesis 50, 10, close parenthesis. Now 50 here is the mean and 10 is the standard deviation. And below this, you write the distribution of probability, n, open parenthesis 50 and 10, close parenthesis. Now notice here that we start to incorporate probability. We are going to use this for the z-score table. Now recall, the z-score table is basically a conversion table from z-score to actual percentages. And these percentages also tell you about the probability that a specific value can be located in that certain portion of the normal distribution. Okay, apart from the given, which is the mean, the standard deviation, and the n, you also need to know what the value or set of values that you are trying to locate. Now, for this specific example, let's say that we are trying to locate values that are more than 51. Now, with that, let's go to the next step, which is to write down the equation. Now, the equation is what is the probability that the value or x is more than 51. So we write it down as p, open parenthesis, x is more than 51, close parenthesis, equal to the probability of z is greater than 51. Since we are trying to convert the value to actual z-score, we are going to use now the formula of the z-score here, because we want to know which part of the normal distribution is 51 or how far 51 is from the mean. And so our next step, step 4, is to compute for the z-score. Now we are going to change the equation a little bit. So that would be probability of x is more than 51 is equal to the probability of z is more than 51 minus 50 all over 10 over the square root of 64. Now we started to incorporate all of the givens that we were able to list down before. So now we have the probability of z is more than 0.8. So basically the z-score that we have here is 0.8. Now that we have the z-score, we will now convert it to percentages or probabilities using the z-score table, which we also call as a standard normal distribution table. Now notice here in the z-score table, we have the rows and the columns. The first column shows you the first two digits of the z-score. So it has the digit in ones place and the digit in the tenths place for the decimal points. And for the first row shows you the values on the hundredths place of the decimal point. So it basically divides your number into two parts. So for our z-score example, it is 0.8. So you can locate it in the first column, 0.8. And since it does not have the hundredths place for its decimal point, or its hundredths place is already 0.0, you start to locate where 0.8 and 0.00 would intersect, which is 0.7881. Now that we know the converted value from z-score to percentages or probabilities, we will now start to plot this probability on the normal distribution curve. Step 5 is to plot the probability on normal distribution curve or the center. So the mean there, as we have defined before, is 50. So we now have 50 as the mean. The next step is to locate which 0.8 is. Now here are simple rules that you need to recall. If z is greater than x, minus the probability from 1 and shade towards the right. So since z is greater or more than 51, we need to minus that from 1. So we have 1 minus 0.7881. So if you try to compute that, 1 minus 0.7881, we now have 0.2119. So in percentages format, it's basically telling you that 21.19% of the probabilities you have here is greater than 51. Now, if z is less than x, keep the probability as is and shade towards the left. And so you can see here in the illustration how it would look like. Always remember to locate the center first so that you would know which part or which direction to shade. And you also have to be careful about where to locate the x. This is why we have the center. So if the center is 50 and what we're trying to look for is 51, so it should be at the right of the mean, which is 50, because 51 is greater than 50. And then the right of 51 means that it is 21% or 21.19% of the whole population, which also checks out graphically because 21.19% should look smaller than the remaining parts of the distribution curve. And the remaining parts would be 78.81%. And so if you're not sure about the numbers that you have computed, it's best to present them graphically so that you will have a full picture of what it looks like. So that's it for understanding the z-score table.